This video will go over the transformations of exponential functions. Now, one of the things to note with exponential functions is some terminology. Whenever we're talking about exponential functions, you will have the base of the exponent function, and you will have the exponent. The exponent is a variable. That is what an exponential function is. Now, if I'm looking over to the Desmos piece, you'll see this function is graphed. Of special note with this function, I do want to talk about a couple of different values for the x and for the y. When x is 0, what that means is y is equal to 2 to the 0 power. Anything to the 0 power is always 1, which is going to give us this piece right there on the graph. That's one of the points we're going to be looking at in the transformations. The other one that you're going to see and we're going to reference is 2 to the first power, which is in this case 2. So when x is 1, y is equal to 2. Now the first transformation that we're going to talk about is the vertical shift. So let's also add these two graphs inside here. Now, whenever you have 2 to the x, and this is plus 3, so what's happening here is this is just moved up plus 3. Now, the original point that we had was 0, 1, and we are adding 3 to that value, which gives us the point, it's kind of covered up, 0, 4. Same thing with the minus 6 that got shifted down by 6 units. So the 2 to the x plus 3, remember 2 to the x is the exponential function, so this shift is 3 units up. And again, 2 to the x is the exponential function, and that minus 6 is 6 units shifted down. The next one we're going to talk about are the horizontal shifts. And if you look at these, the difference with this is where is the shift happening? You'll notice for both of these, this x minus 2 and the x plus 1, that remains in the exponent. Whenever that happens, the shift is opposite of whatever the sign is. So for this first one, the one that I have in blue, this gets shifted 2 units to the right. And the one that I have in green is shifted 1 unit to the left. And that is because it is opposite of what the sign in front of the shift is when it is a horizontal shift. All right, vertical stretch and compression. So vertical stretch and compression, let's take a look at those. Now with vertical stretch and compression, I want you to think about it as either a pull. So if you're a stretch, if you imagine pulling up to down, it makes it thinner. A compression is making it wider when you're talking about both of these, and these are graphed in both the red and the blue. What I want you to think about this again is look at that first point, that point 0, 1. What happens to it? For the graph that I have here, I'm multiplying that value times 6, so that's getting pulled up this way, and it's making the function appear longer or taller. A compression, for the next one, this is getting, the 2 raised to the x power is getting multiplied by 1/2, so the output is getting smaller, so it's getting pushed down and squished down. And this point is 0, 1/2, and up here that is increased by 6, so that is by 0.6. And the way we say that is this is a stretch by 6 units by a factor of 6, and a compression by 1/2. The next transformation that we have is a horizontal stretch and compression. And with the horizontal stretch and compression, we can't look at this one point right here, because if you look at that point 0, 1, it's the same for everything. So we're going to have to, in this one with horizontal, it's how does it change horizontally. So it's left or right. So we want to go ahead and look at the point on the original graph of 1, 2. See if I can get it. It's close enough. So what happens with this point? When x is equal to 1, y is equal to 2 of the original value. What happens going to the blue graph, which I have 2 to the 3x, it's getting compressed by 1/3, because horizontal does the opposite of what you would think, and by the 1/5 is getting stretched. So let's take a look at this. So whenever I have a 1/5 inside here, that actually becomes a stretch by 5 units, and the 3 times x is a compression by 1/3. Whenever you have horizontal, whenever you have anything that's being raised to the exponent, it is the opposite of those values. All right, and then the last one we're going to talk about are the reflections. And I'm going to do these separately. I think it's easier for us to see. When I have y to the negative 2x, that is a reflection, a top-bottom flip around the x-axis. And then when you change the exponent to a negative, that is a left-right flip around it. Hopefully this helps with the reflections and other transformations. And just one note, this is true for any base b that you have.